Hey everyone, and welcome to today's Explainer. We are jumping right into a completely fascinating and honestly pretty sobering paradigm shift that is unfolding on the modern battlefield right now. We're going to break down a recent CNN report sourced via the Sonophiles Observatory that outlines a massive evolution in military tactics. We're talking about a fundamental shift where incredibly innovative, low-cost tech is stepping up and directly challenging highly advanced established military dominance. I mean, think about it for a second. What actually happens when multi-billion-dollar defense budgets, systems that took literally decades to engineer, are suddenly rendered totally vulnerable by seemingly off-the-shelf, budget-friendly technology? For decades, the whole foundation of global security has rested on the idea that the military with the fanciest radars, the strongest electronic jammers, and the most expensive interceptor missiles is, without a doubt, going to control the skies. But, as this source material shows us, that exact assumption is being put to the test right now. In fact, it's being completely bypassed by a surprisingly simple yet devastatingly effective piece of tech, the fiber optic drone. So we are going to unpack exactly how this monumental shift is happening, relying purely on the rigorous details from the report. Let's get into it. So here is our roadmap for today. 1. The asymmetric warfare shift. 2. Anatomy of aerial weapons. 3. The fiber optic advantage. 4. Electronic warfare vs. emerging tech. 5. Disrupting defensive positions. And finally, 6. A growing war of attrition.
All right, starting with Section 1, the asymmetric warfare shift.
To really grasp the gravity of this report, we have to establish a baseline of what modern military dominance usually looks like. And that brings us to this foundational quote from the CNN report, which notes that Hezbollah's attacks have exposed the limits of technological superiority. Let's just impartially unpack what that actually looks like in a combat theater. For years, established militaries have leaned on these incredibly complex, deeply integrated electronic shields. Picture the sheer scale here. We are talking overlapping systems of high-powered radar, continuous radio frequency jamming networks scanning the horizon, and kinetic interceptors, which are essentially these incredibly fast, massively expensive missiles built just to shoot down incoming threats midair. These defensive systems represent trillions of dollars in R&D. But asymmetric warfare, it completely flips the script. It uses unconventional, low-cost tactics to perfectly exploit the heavily engineered blind spots of a much more armed opponent. What the report highlights here is that these advanced, immensely expensive electronic systems are right now struggling against a threat that costs a tiny, tiny fraction to make. That supposed technological superiority is basically being sidestepped.
Moving on to Section 2, anatomy of aerial weapons.
So how exactly are these low-cost systems pulling this off in the field? Well, the report lays out a highly specific tactical deployment path that brilliantly shows just how much control operators have now. Look at this sequence. First, the drones maneuver precisely between damaged buildings. This is a vital tactic. By flying super low, they use the dense urban terrain to literally hide from radar. Simply put, radar needs a clear line of sight to bounce signals off a target, right? If a drone is ducking behind a concrete wall, the radar just can't see it, period. Second, they navigate along dirt roads, again, staying incredibly close to the ground, deliberately staying below the scanning horizon of traditional air defenses. Third, they meticulously locate their specific military hardware targets. And then finally, the interface flashes bomb-ready. You have to realize, this is not some pre-programmed GPS-guided missile just blindly falling toward a coordinate. This is an active, real-time hunt guided by an operator. The system can literally be steered through complex environments right up until the exact millisecond of impact.
Which brings us to Section 3, the fiber optic advantage.
Now, you might be wondering, how on earth is this level of real-time control happening in a combat zone that's completely saturated with electronic jamming equipment? The answer is a physical tether. And the reach of this tether is honestly staggering. 15 kilometers. Just stop and think about that distance for a second. The drone is unwinding this ultra-thin, almost invisible fiber optic cable the entire time it flies. You might think, wouldn't a cable that long just snap or get tangled up? Well, the ingenuity is that the spool of cable is actually housed inside the drone itself. It pays out smoothly backward as the drone flies forward, leaving this fragile thread suspended perfectly motionless in the air, rather than dragging it along the ground. Over that massive 15-kilometer stretch, that tiny glass or plastic thread is sending back a pristine, live, high-resolution video feed straight to the operator. It isn't relying on satellites, it doesn't bounce off cell towers, no radio frequencies, no Wi-Fi. It is quite literally hardwired. That physical connection is the absolute game changer here, giving the operator absolute visual clarity from miles away. And the strategic consequence of having that physical cable is massive.
Israeli researcher Yehoshua Kaliski points out in the report that the complete lack of an electronic signature makes determining the launch location almost impossible. To really get why this is such a headache for defenders, we need to know what an electronic signature even is. Standard military tracking relies on detecting invisible radio waves. Whenever a normal drone operator pushes a button on a controller to steer, defense systems can instantly detect that burst of wireless energy. They track it, triangulate the angle, and boom, they map exactly where that signal came from. But because a fiber optic drone sends every bit of data down an enclosed string of glass, it emits absolutely zero radio frequency. It is totally electronically silent. There are no ripples in the electromagnetic spectrum for the radars to catch. So that traditional method of tracking the signal back to the source, totally nullified. The origin point is completely invisible to the very systems designed to find it.
Okay, Section 4, Electronic Warfare vs. Emerging Tech. When we put these two paradigms side by side, a really dangerous mismatch emerges. Traditional electronic warfare works on a very specific premise. Its main defense is throwing up a massive invisible wall of electronic noise. It's radio frequency jamming, essentially screaming so loudly on wireless frequencies that a drone loses its connection to the base, loses its GPS, and just crashes. And as we just talked about, it relies on detecting those electronic signatures for early warning. But then, enter the new reality. Fiber optic drones. Because of that physical cable connection, they are 100% immune to wireless jamming. It literally doesn't matter how much electronic noise a defense system pumps out, you cannot jam a physical piece of string with radio waves. And with zero electronic signature, those multi-million-dollar early warning systems are flying blind. The established defense is burning massive amounts of energy trying to block a radio wave that doesn't exist, while the new asymmetric threat just casually flies right past the shield. Just to show how terrifyingly effective this unjammable technology is, the CNN report details a very specific tactical incident. First, a fiber optic drone successfully targeted an Israeli tank, causing casualties. But what is really notable and deeply concerning from a strategic view is what happened next. A coordinated secondary strike was launched directly at the medical evacuation helicopter that came to help. Because these drones cannot be jammed, the attackers have this uninterrupted, high-definition awareness of everything happening on the battlefield. They can orchestrate these complex, multi-stage attacks with total confidence. They can watch the initial strike live, wait for the emergency response to roll in, and then deploy secondary weapons, knowing for a fact that their command signals won't be cut off by the intense electronic warfare measures that usually protect a medevac operation. Let's look at Section 5, Disrupting Established Defensive Positions. So how does a highly advanced military even respond when its multi-billion-dollar electronic shield gets bypassed? The report outlines a fascinating and honestly kind of surreal irony here. Faced with an unjammable threat, these modern forces are having to fall back on the most rudimentary defense imaginable: physical barriers. We are talking about literal nets. The report notes that heavy protective netting is being strung up over military sites, and incredibly advanced military vehicles are being covered in wire netting. It's a desperate attempt to physically tangle the drone's rotors before they can detonate. An Israeli military source even admitted to CNN that right now, these nets are almost the only available solution. Picture that visual contrast for a second. You've got cutting-edge armored vehicles packed to the brim with advanced computing and radar, hiding underneath basic low-tech rope and wire netting. And worse, the report acknowledges these nets aren't foolproof. They're highly vulnerable to simultaneous swarm attacks. If you send multiple drones at the same target all at once, they can easily overwhelm both the surveillance cameras trying to spot them and the physical nets trying to catch them. Finally, Section 6, a growing war of attrition. At this point, we're moving way past isolated incidents and looking at long-term strategic consequences. The CNN report concludes that this whole dynamic is evolving incredibly fast. The attacking forces aren't just staying static. The report explicitly says they are learning quickly. They're refining their coordination, taking their accumulated experience, and turning these cheap unmanned systems into a continuous, reliable weapon of war. And on the flip side, established militaries are left constantly scrambling, trying to adapt to a threat that fundamentally ignores their main defensive architecture. This has basically turned the battlefield into a highly dangerous war of attrition. The financial asymmetry is just wild. Launching an attack is incredibly cheap, meaning they can do it constantly. Meanwhile, the physical and psychological toll of defending against it mounts every single day. Defenders are stuck in a state of exhausting vigilance, knowing an unjammable threat could slip through at any second, all while their own supply of high-tech interceptor missiles is limited, crazy expensive, and strictly exhaustible. So the paradigm has undeniably shifted. Multi-billion-dollar high-tech electronic shields are being bypassed by the simplicity of a literal spool of glass. Which really leaves us with this final, critical question to consider. How do advanced militaries adapt to this new era of low-tech, asymmetric warfare? When a trillion-dollar electronic defense grid can be completely defeated by a drone quietly unwinding a 15-kilometer thread, the entire foundation of modern military strategy and defense has to be reevaluated. The balance of power is shifting, not through overwhelming firepower, but through simple, brilliant, unjammable ingenuity. Thanks so much for joining me for this explainer. Keep questioning the systems around you, keep learning, and we'll see you next time.